Hey, what's up everyone? Welcome back to another video. Today we're going to be talking about mass, the concept of mass as a dimension, and the concept of mass in chemistry, and how to write a mass balance, all from a chemical engineering perspective. So in the last video we talked about the main equations we see in chemical engineering. When in doubt, accumulation equals in minus out. So that means, for my analogy, I like to see chemistry, calculus, and physics coming in together, and what you get out is chemical engineering. Let's see what that means. We've also talked about dimensional analysis. There are 7 base dimensions including mass, length, and time, and from the 7 base dimensions we can derive many other variables in physics. So we're going to be talking about the very first dimension, which is mass. So like I said, we're going to be starting by introducing what the concept of mass is, and then building up from those fundamentals to describe what is mass from a chemical engineering perspective. Here's my best definition of what mass is. This one slide hopefully encapsulates almost everything about mass. Mass is the fundamental base dimension that is the number represented by a scalar quantity that tells you how much stuff an object has in kilograms. It is the proportionality constant to force and therefore governs the inertia and the motion of an object. Mass is not a force and it cannot be created or destroyed. What does that all mean? So what better way to think about mass than to just prime ourselves to think about just heavy objects. Just think about anything that's actually literally heavy, like a heavy couch or a heavy weight. If you're working out, you're actually working out your muscles. And so mass and weight are used interchangeably in real life. But in chemical engineering, mass is going to be different than weight. And last time I told you guys about the periodic table, and I told you to memorize about 12 elements. So let's talk about the elements real quick. So mass is matter. Matter is just stuff. So here we have an atom. It has a proton and an electron. What atom is this? If it has one proton and one electron, what atom is that? Well, that's going to be the hydrogen atom. And here are the fundamental constants. There's a note about memorizing that I want you to think about. Sometimes you don't really need to memorize stuff because you can have access to the internet, but if you memorize certain quantities like the mass of a proton and the mass of an electron, that's going to really help you for your equations and your calculations. So in this case we have the atom that is hydrogen, and so we can calculate certain quantities using these constants. So for hydrogen we have one proton and one electron, and so we want to calculate the mass of hydrogen. So I'm going to use this equation, the mass of hydrogen. So the mass is m, and that little h stands for hydrogen. So all we have to do is add up the number of protons, neutrons, and electrons. And notice that there's 0 neutrons, so they cancel out. And we look at our fundamental constants. Pause the video if you want to calculate it yourself. We look at our constants and we add up those values. So in this case, it's just the mass of the proton plus the mass of the electron. And I'm going to neglect the mass of the electron because it's 2,000 times smaller than the mass of the proton. So it's about 1.67 times 10 to the negative 27 kilograms. Kilograms is the unit for mass, and the dimension for mass is just mass itself. So mass is the amount of matter in an object. Let's do one more, so let's do oxygen. So oxygen is going to be a larger atom. It has 8 protons, 8 neutrons, and 8 electrons. So again, we're going to add up the number of protons, neutrons, electrons in the system. Okay? And so again, we're going to neglect the mass of the electron. You can add it if you want to, but you're going to realize that you can neglect it and still have an accurate answer. So the amount of mass of one oxygen atom is 2.67 times 10 to the minus 26 kilograms. So that's a very, very small mass. So mass is the amount of matter in an object, and the matter is protons, neutrons, electrons. Since the mass of the electron is negligible, the mass of something is the total amount of the protons and neutrons in an object, and it's measured in kilograms. Let's look at another example. Water bending. I'm a waterbender. That's my nation. Okay, so we want to study the chemistry of water. So in this video, we're not going to be talking about the chemistry of water, but that's very important because that gives us life. Without this chemistry, we can't even survive. And so we want to calculate the mass of water, H2O. So we need the mass of 2 hydrogen atoms and the mass of 1 oxygen atom. So that's going to be the mass of 1 water molecule, 1 H2O molecule, is going to be 2 times the mass of 1 hydrogen atom plus the mass of 1 oxygen atom. So we add those together. We already solved for the mass of the hydrogen atom, and we already solved for the mass of the oxygen atom, so we can solve for the mass of the H2O molecule. So that is going to be 3.004 times 10 to the minus 26 kilograms. Okay, so now we're going to introduce another concept, which is moles. So moles is technically another fundamental base dimension because we're looking at the moles versus the mass of something. So moles, we're just counting up however many atoms there are. So if we have one molecule of water, that's just one water molecule. That's just one quantity of water molecules, right? So the mass of this one water molecule is 3 times 10 to the minus 26 kilograms. What if we have lots and lots of water molecules, like billions and trillions of them? We're gonna have like a whole glass of water. So even in just one glass of water, there's more than I don't even want to say trillions, it's more than quadrillions. It's gonna be up to the 10 to the 23rd water molecules in 1 mole of water. Like, think about, like, comprehend that. If you, the first time I learned about moles, it's just so hard to comprehend how vastly large that number is. 10 to the 23. That's more than billions. That's more than trillions. That's more than quadrillions. I can't stress this enough. How many molecules of water are just in one glass of water, let alone a whole ocean, let alone the universe? Okay, so 1 mole of water is going to be 6.022 times 10 to the 23rd. So that's a number. That's a number. So that's how many moles of water there are. So how do we calculate the mass of the water? So all we have to do is multiply the mass of one water molecule times the total number of water molecules. So in 1 mole of water, that's going to be 6 times 10 to the 23. Memorize that. It's Avogadro's number times 3.004 times 10 to the minus 26 kilograms per 1 molecule. So that's going to be 1 mole of water is 1.8 times 10 to the minus 2 kilograms, or that's going to be 18 grams. So notice how we're doing unit conversions. We're doing some dimensional analysis a little bit. Okay, so 1 mole of water is going to be 18 grams. So this concept of mass versus moles, they're very similar. They're very similar, so there's a conversion factor. So we said that one water molecule has a mass of 3.04 times 10 to the minus 26, and 1 mole of water has a mass of 18 grams. So you can imagine like 18 grams of water. That's like not even a cup of water. That's just like a little bit of water. So we can define something called the molecular weight. So the molecular weight of a substance is just the ratio of the mass to the moles. It's just a ratio, mass to moles, mass divided by moles, grams per mole. So if we know the molecular weight and we know the mass of something, we can calculate the moles of something. If we know the moles of something and we know the mass of something, we can calculate the molecular weight. So if we know two of these quantities, we can calculate the third. So that's molecular weight. Now we can talk about the fundamentals of mass balance. Chemical engineering is all about mass balance. It's all about energy balance. So we can talk about it. So let's just say we have a box. And in this box, we put in, I don't know, 5 balls inside the box. And then there's 3 balls. We take 3 balls outside the box. If I open the box and look inside the box, how many balls are going to be inside the box? Literally just 5 minus 3 is just 2 balls. That's mass balance. It's honestly that simple. It's that straightforward. All you have to do is just add everything coming in and then subtract everything coming out. So let's do it again. Let's add something else. Let's say 5 kilograms of water are going into the box, and then we take out 3 kilograms of water. So again, how much water is left in the box? It's literally just subtracting 5 minus 3. So it's just going to be in minus out is 2 kilograms of water. Okay? So in general, if we have a box, we have whatever's coming in and subtract whatever's coming out. So how much mass is left in the box? Again, it's just in minus out. That's the total mass that's left inside the box. That's what a mass balance is. This is called mass balance. We do it one more time and generalize it. So we're adding different color balls, we're adding different molecules, different types of stuff. It's these funky looking equations. If I have a sigma, the sigma just means that I'm adding all different kinds of stuff inside the box. If I'm adding, I don't know, red balls plus orange balls, then I'm gonna add up all those different types of balls. If I'm adding water plus orange juice plus methanol, then that's gonna be my mass balance coming in. So the total equation for mass balance, whatever's left inside the box, is you add up everything coming in and you subtract everything coming out. That's mass balance. So all of these equations that we're talking about, these can all be utilized to calculate mass balance. So technically, at the end of the day, when you're doing mass balance, you're calculating the number of protons and neutrons in a system. So the protons and neutrons are the fundamental particles that have mass. And we can use molecular weight, which is in grams per mole, to add to our system of equations. If we know different parts that we're adding up together, like water or orange juice, we can add up all those things together. So all these equations we can use in our tool belt. Now we're adding, as engineers, we're adding this to our tool belt that we can use to solve problems. So if all those equations are looking funky and unfamiliar, just remember, when in doubt, accumulation equals in minus out. So now you understand the conservation of mass. Conservation of mass just simply means that stuff can't be created or destroyed. I mean, if I open up the box and I know there's supposed to be two, and I see that there's three, that's gonna make no sense because that means a ball is appearing out of nowhere. And if I open up the box and I see zero when I only took out three, then that's gonna make no sense either because where would it go? So mass balance just means that you just can't make stuff out of nowhere. It has to balance out. Whatever's coming in has to be equal to whatever's coming out. That's what mass balance is all about. Oh, that kind of rhymed. That's it for this video. Please let me know if you have any questions. I know younger me would be like, wait, where are all those equations coming from? Like old me would just be asking like, wait, how did you just make up those equations? How did you just make up molecular weight? Well, that's what you do as a scientist or as an engineer. You make up your own equations, but not really. We didn't make them up out of thin air. We're describing real systems with mass balance, okay? And in the following videos, we're gonna do tons and tons of examples. I already have plenty of homework problems on my main channel, and then from here on out, we're gonna be focusing on lectures on this channel, and then going over for the rest of the concepts. So please let me know if you have any questions because this type of content is what we're going to be used to describing this entire table, and it's going to help for all your classes, whether you're taking chemistry, calculus, and physics, or you're already taking your chemistry mass balance courses, or all the way if you're taking fluid mechanics, transport phenomena, mass transfer, thermodynamics. All these concepts are fundamentally very similar, okay? If you enjoyed this video, please don't forget to share this with your friends, family, and your dog. Thank you.